So Psalm 34, 11 through 14. Come, my children, listen to me. I will teach you the fear of the Lord. Whoever of you loves life and desires to see many good days, keep your tongue from evil and your lips from telling lies. Turn from evil and do good. Seek peace and pursue it. And I know one of the other verses that I had in our lessons this week had to do with the fear of the Lord. And I thought, sometimes the idea of the fear of the Lord, like there's a verse in scripture too that I'm sure you've heard, the fear of the Lord is the beginning of wisdom. And the fear of the Lord is kind of in some ways a little bit of an enigma or confusing or kind of like really broad and general and hard to maybe grasp as to what it really is. But here is a verse that brings a lot of clarity. It just says, I'll teach you the fear of the Lord. And then it gives us this little list of things that fit right into what it means to fear the Lord. But it has this little kind of preface, kind of promise is like, whoever of you loves life. So somebody who wants to fear the Lord is really somebody who loves life and desires to see many good days. And the things that it tells us that can be a representation of us fearing the Lord is to keep our tongues from evil and our lips from telling lies. Now, everybody makes mistakes and we all choose to sin at times, but it's that heart intention of what do you want? You want to grow to where your tongue is being used for good and not telling lies, of being honest and things like that, and turning from evil and doing good, and to seek peace and pursue it. That this actually takes action, and it also takes restraint. To keep your tongue from evil, it takes self-control, and to keep your lips from telling lies, it takes restraint in the sense of being willing to deal with maybe some shame of something that didn't go right, and you got to tell the truth about it, but you'd rather hide it. It takes restraint to hold back those feelings of wanting to protect yourself, but in fact of then just being honest. But turning from evil when evil is before you and you've got a choice to make, turning from evil and instead doing good, or seeking peace. It's actually an action, and pursuing it. So I guess I just thought I'd share this because I thought it was a good verse that brings some clarity to what it means to fear the Lord. So kind of some action steps, if you will. So I thought that was kind of cool for a verse that from other places can be kind of confusing or hard to know exactly how to apply it. So there we go. All right, Psalm 34. Here's our problem.
Bailey got kicked out.
Yeah, I saw that. Thanks. We're just going to keep going. If I see her it pop in on the participants, I'll let her in, obviously. If you see her sitting there waiting, let me know. But our problem of the day follows with corollary 53.2, relating to parallel lines and transversals. And if you remember, Theorem 53 and Corollary 53, 1 and 2, they had to do with if there are parallel lines and transversals, that if there's a proportionate relationship on one side of one, or on one transversal, then there's a proportionate relationship on another transversal, that those parallel lines intersect. Okay, so if you look at this, I'd like you guys to work through this. And maybe for the sake of going a little bit faster, I'll have you talk me through it and we'll do it on the board. Okay, so how would we find the value of B using the given information that we have?
We could make a proportion and then cross multiply.
Okay, all right, so Mark gave us that idea to start with. One of either Izzy or Gilbert tell me how to set up a proportion? There's actually a couple ways, so don't be freaked out I don't know exactly which one, I could get it wrong. There's a couple right ways. So any ideas? Either let's try Izzy or Gilbert first.
Izzy can go first.
Oh, I think Izzy just got kicked off, actually. It looks like.
She can still go first. Oh, Mark.
Izzy, Gilbert is nominating you to try it. Do you want to try to set up the proportion, or are you going to pass it back? Can you hear me, Izzy?
It's really breaking up.
Okay. Well, if you want to, you have my permission to drop off and watch the video later. That would be okay. Okay. Well, Gilbert, I'm going to put you on the hot seat then. Can you at least try? What would be your best guess of setting up a proportion to find out what B is?
It would be. So we're trying to find what B is, the value of B.
Right, so we have to proportion.
Would be 16.
Well, don't worry about what the answer would be. I just mean, like, what is the proportion? Like, our step 1 is to set up a proportion. So we have to see, well, which sides should be in ratio. So, like, what are, like, for example, if I ask it this way, if I look at the little segment that is 12, what's the corresponding segment on the other transversal that's related to?
24. 9.6.
6. Yeah, you always go right straight across between the two parallels, okay? So we'll say 12 over 9.6 has to have the same relationship as, and then what would B go up here, or would 24 go up here?
1 second.
Just think about it this way. We started with a segment 12.
B.
Yeah, so B would go up here. We have to keep these have to be corresponding segments. So these are, let's see. Yeah. So then B goes up here because 12 and B were both on the same line. And, or I'm sorry, they have to be on the same line. Those aren't the corresponding segments. So they have to be on the same line. There we go. And so then over 24 here. So now we've got our proportion. And Mark gave us step 2 as well, and he said to cross multiply. So we go ahead and we can cross multiply, and we get 9.6b equals 12 times 24. Okay. All right, why don't you guys go ahead and do 12 times 24 if you haven't already?
That is 288.
Wait, what did you say, Mark?
288.
Do you agree with them?
Yeah, that's
All
what I
right.
have too.
Perfect. Okay, so 9.6b equals 288, and then we still need to divide by 9.6. So go ahead and divide by 9.6, and we will find out. So you guys go ahead and do that.
What was it? What did you say to do?
Because we're solving for b, so we had 9.6b, so we have to divide both sides by 9.6.
Okay.
30?
Okay, yep, 30 sounds right. So b is 30. And if we take a look at the original values, like take a look at the diagram. If we think about 9.6 to 24, it's almost 10. 10 is to 24. Think about 12. 12 compares to 30. Okay, you can kind of see it should be a bigger number, right? Because 9.6 is to 24. We go for a smaller one to a bigger one. Okay, so it should be following that same kind of pattern on the top. So that's coming from yesterday's lesson. How did you guys feel like yesterday's lesson went when you're doing the homework? Pretty good? How about you, Gilbert?
Fine, I guess.
Fine, okay. All right, I didn't have a chance to grade it yet, but anyway, it looked like you guys were on the right track when I just usually kind of quick scan them and then click a flag so that I know which class and stuff it's for. Okay, so theorem 55. We have a new theorem today, and it looks like this, okay? And it has to do with angled bisectors. So something that we've learned about before, shouldn't be too hard, I don't think. It says the bisector of an interior angle of a triangle divides the opposite side internally into two segments, which have the same ratio as the other two sides. Okay, so let me unpack this a little bit. I'm gonna go ahead and I'm gonna draw this diagram. You guys can go ahead and reread it to yourselves, see if it's starts to make sense to you. Okay, so what's going on here? It says if the bisector of an interior angle. So we have to like start there. I have a triangle, and I'm going to look at the vertex angle, just to pick an angle. And I'm going to find its angle bisector. So I've got to have a bisector. Okay, so, and then I'm going to say, well, these should be two equal segments. They're not perfect because I'm not using compass, but you get the idea. Can you guys see my drawing okay? Or should I stop the screen share?
It's fine.
It's fine? Okay. It's
Fine.
fine? Okay, I can make this a little thicker. Okay, so there's my angle bisector in my dotted line. And what it's saying is that it divides this third side, this bottom, the base, into two segments that are proportionate. So I'm going to label this segment here, that one C, and this segment here, D. Okay. So they become proportionate in the same relationship. So if I compare the two original sides that are the rays of my angle that I bisected. So I'm thinking of the ratio of the two sides that would make like the rays of the angle, okay? So I'm going to compare A to B as my first ratio. Now, A is the short side, okay? B is the long side. Well, when I look at here, C is the short side, so we're comparing the short side is to the long side. So these are both the short sides. So we're comparing them, short to long. Okay. And this theorem is saying as long as when I cut this angle, if I use the angle bisector, I will create proportionate segments of that third side. Okay, so I could redraw this diagram in different ways. I could use a different angle bisector of a different angle here. So if I did this, I could do it from this angle as long as I have the angle bisector. If I bisect this angle, it's going to cut this, if I made this like side A and side B, okay, then it's going to be related. This would be C and this would be D. So these two sides, the relationship of these two first sides that make up my angle rays in the triangle would be proportionate in the same way as these two sides that are like created if I were to divide these. Okay, so I'm cutting these apart into two segments. That proportion is the same. And that's what Theorem 55 is saying. Gilbert, does that make sense to you? To you, Mark?
Yep.
All right, so I have another little diagram that's colored on the next slide. So I liked this one too. So this one you can see they chose angle A as the angle to bisect, and when they drew the angle bisector, which is the black line, they formed a point at D, and then we end up with BD, which is the longer of the two segments that are created, is to CD, is to the shorter segment, as BA, that is the longer side, is to the shorter side, AC. Okay, so that's just another way to write it. That one has color. So anyway, so then what we're going to do is we're going to apply it. We're going to find X. So kind of like what we've been doing with proportions is anytime we know there's a proportionate relationship, if we have a missing value, we can use the rules of proportions to help us find that missing value. So that's what we're going to do. So in a problem kind of like this, if we have some known sides, like the side AC is 18 and side BC is 24, I know that if I take the angle bisector, which angle is being bisected in this light blue diagram? We've got triangle ABC, and which angle is being bisected in the triangle?
C.
Okay, so angle C is the one being bisected. So it's the side that's opposite angle C that is being divided or cut up proportionately. Okay, so what happens is side AD is related in the same scale factor to side AC as side DB is related in the same scale factor as it is to side BC. Okay, so it becomes a proportionate relationship, and so we can set up a proportion that will help us to solve and find out what X is. What is that missing segment length of BD? Okay. So there could be situations where you might not know a certain length, but because you know there's a proportionate relationship, you can find it out. So to review kind of our steps that we would solve, there's just a little note I put here, is that the reason those blue arrows are there is just to show the corresponding sides. That segment AD is the shorter of the two segments that are cut, and then side AC is the shorter of the two triangle sides. So that's why when I wrote my diagram up here, I always kept my ratio in the same format of short to long. So short to long, short to long. So we're gonna do that same kind of thing. Okay, so our step one is to identify the corresponding sides, which are already here. And just to get that in your head, step two, set up a proportion. Okay, so let's go ahead and see if we can set up a proportion. You guys look at the diagram and see if you can think about what that proportion would be. Okay, so any ideas how we could set up the proportion? The theorem says that the two original.
So would it be?
Go ahead.
Would it be something like 18 over 24 equals 12 over x?
Yep. So 18 is to 24. So it's saying those other two sides of the triangle, the full sides, are related to each other in the same way. So we started off with 18. 18 is the shorter length, is the way that Mark picked it. And so we have to keep it equal, and then he put the longer side on the bottom. So we got to follow that same pattern. And so when he gave me the other side of the ratio, he put the shorter length of the two on top. So the 12 went here, okay, and the x went down here. Okay. So 18 is to 24 as 12 is to x. So it's saying that's the relationship. However 18 increases to 24, 12 must increase to x. And I'm not talking about addition, remember, talking about multiplication or division. So then Gilbert, how do we solve this? How do we find out what x is then?
A second. Do we do what's it called? I can't. No, I don't know.
Can you don't have to know what it's called. Can you tell me just how to do it? Like, what do I do?
Do we like cross multiply or something?
Yes. Okay. So when we cross multiply, and to do the extremes, we would get 18x. And for the means, we get 24 times 12. Wasn't that what we just did? Right? We just did that, right? That was 288. Okay. All right. So then we get 18x equals 288. And then, so your step two was just to solve it, okay, and simplify. So then we divide by 18. So you guys can go ahead and divide by 18, see what you get.
16.
Okay, 16 is right. Yeah. So what happens is then is because of the proportionate relationship and knowing that segment CD was the angle bisector, then that missing length DB is 16 because it's the same scale factor, has the same like ratio of similarity from those two segments as the other two sides have. All right, so anyway, like I said, I was just going to present one theorem today, and I felt like this is kind of, it's a new thing dealing with angle bisectors and requires you to see inside the triangle, and so I didn't want to overdo it as we've kind of gone through a lot kind of quickly, especially yesterday. So our homework is on page 201, just numbers 1 through 4, and then number 10. And those are the ones that deal with Theorem 55. And so what you're going to want to do is, for Theorem 55, it's going to like refer to the drawing under, or well, next to Theorem 55, or it's kind of under next to. So in Theorem 55 in your book, it has a triangle, and the triangle is RST. Okay. So what I would do is look on your book on page 200, which is where Theorem 55 is, draw the diagram on your notebook paper so that you don't have to keep looking back at that. So just draw the diagram that they have, and they're talking about triangle RST, which is the big triangle, and they drew the angle bisector in there, which is TM. If I were you, I'd draw the bisector with a dotted line. I prefer to do that just mentally or visually. It keeps me kind of focused on the triangle just being the solid lines. So the diagram that you'll need is like this. And so it's R, T, S, and then M is that point where the angle bisector meets the other side. So then they labeled this angle X and angle Y. So I would suggest drawing that diagram. In your homework, if you'd like, we have time, we could go through one of those if you'd like. Actually, what I would suggest is we could, I didn't put an example. What's that? Go ahead.
Nothing.
Oh, okay. The one thing is number 4 is like not really different. It just works backwards. So why don't, do you guys have your books with you?
Yes.
Why don't you open to page 201, and I'm going to show you a little bit about number 4, just to make sure that one doesn't throw you for as one step that's different. You've done something like it before, so I don't think it should be like, but so number 4 says, in Theorem 55, if Rm is 3, Ms is 4, RT is 7 1/5, and TS is 9 2/5, does TM bisect angle T? Well, remember the theorem said that if we use the angle bisector, we should have a proportionate relationship. So what would we expect to be true if we plug in all 4 of those lengths into a proportion correctly?
For them to make an equal proportion?
Yeah, so we would like, it would balance on both sides when we cross multiply. So you did something like that before the other day. So it's the same kind of idea. So we could go ahead and look at that diagram. So I accidentally erased it, but it's quick enough, I can redraw it here. So we got a triangle RTS. So R to T to S. And we've got the angle bisector going down here, meeting at N. And we've got our congruent angles, X and Y. And so they give us the information in number 4. RM is 3. And MS is 4. RT is 7 1/5. And TS is 9 2/5. So remember that what we have, Theorem 55, said that if the way that the long side is related to the short side should be the same proportion as the way the longer segment that's cut is related to the shorter segment that's cut. Okay, so how would I set up my proportion then to check and see if it balances?
Cross multiplying.
Yeah, cross multiplying. So I'm going to say, again, I'll go from long. This time I can go from long to short. As long as I'm consistent, it won't matter. So the long side was 9 2/5 over the short side was 7 1/5. As then I have to use the longer of the two segments, which is MS, the longer of the two segments, as 4 is to the shorter one, which is 3. So my step 1 was to set up a proportion. Okay, and step 2 really is still the same. It's going to be cross multiply, but the difference is when I cross multiply, I'm not solving for x. Okay, I'm checking for equality. Okay, so my final thing is just going to be to check for equality. If we get the same answer on both sides when we cross multiply, then that means that line TM or segment TM is in fact the angle bisector. If we get two different numbers on each side, that means that TM was not the correct angle bisector. In fact, then I'd have to erase these little congruent marks. Okay, so if we cross multiply, I'd be going ahead and doing 9 2/5 times 3, and that should equal the other cross product, 7 1/5 times 4. Okay, so then you have to go back and use some of your pre-algebra skills of multiplying mixed numbers and simplifying that way. Okay, I'm not going to go ahead and finish it all the way because I think you guys should be able to do that, and I'll let you decide. So if it ends up equals, both sides are the same, then TM is the angle bisector. Then it would fulfill Theorem 55 correctly. So if it equals, you'd say yes, and if not, you'd say no. So that's just that should, I think, be the only difference. Otherwise, the rest of them are mostly just finding the missing values. Number 10, it has it in variables, so your answer is going to have variables in it. You won't be able to solve for just a number. And that would be it. So, so that's what I've got for you guys today. And if you guys don't have any questions, you are free to go. If you do, I'm here to answer them.